Hello, this is going to be lesson B1, part 2. It's going to be on functions. Before we can talk about functions, we're going to talk about what is a relation. A relation is a relationship that can be represented by a set of ordered pairs. So here's our ordered pairs. Ordered pairs has x and a y value. So a relation can be represented by different forms. It can be represented by a set of ordered pairs. These ordered pairs could be represented by a diagram, okay, where 1 connects with 10, just like 1 comma 10, okay, and 4 and 4. Okay, I made a little mistake here. I was supposed to connect 2 with 8 and 3 with 6, so I made a little mistake there, but this shows that ordered pairs can be represented by diagrams. Okay, also can represent the relation using a coordinate plane. Also can use it represent using a table. Okay, when we talk about a relation has domain and range. Domain is the set of the first coordinates. So if you notice, the first coordinate here is 1, 2, 3, 4. So domain is this right here. If you have a diagram, the domain is very easy to find. You just look on the first circle there. If you have a coordinate plane, points on a coordinate plane, basically you're just looking for your x values every time a point occurs. And if you have a table, the domain values would be on the x column. The range then is the set of the second coordinates, so it would be the second coordinate of each ordered pair. On a diagram would be the second circle where the arrows point to, and on a coordinate plane, the range would be found by looking at the y-axis. So this would be 4, 6, 8, and 10, and on the table would be the y values. Now that we talked about relation and parts of the relation, we can talk about function. A function is a special type of relation that pairs each pair. I need to make a correction here. That pairs each domain. Let's cross that out. Is a special type of relation that pairs each domain value with one and only one range value. In other words, if I have a set of numbers, a set of ordered pairs, basically the x value cannot repeat. And in this case, the x value doesn't repeat, so then it is a function. Over here, if you have a diagram, it's very easy to see if you have a function or not. And if it is a function, you only have one arrow coming out from the numbers on the left. In other words, only one arrow coming out from the domain values. If you have a graph, basically you use what is called the vertical line test. Basically, imagine a vertical line moving from left to right. And as you move that line from left to right, you're checking that that line only touches one point at a time. So in this case, if I move my pencil here, I'm seeing that the pencil only touches one point at a time as I move from left to right. And if it's a table, basically you're making sure that the x value don't repeat. So let's look at example number 1. Example number 1 is asking, is this set of ordered pairs a function? And if you notice, the x values don't repeat. So we can say, yes, it is a function because the x values don't repeat. Okay, now this problem 2, we're going to practice on translating this set of ordered pairs into a diagram. So basically, all you have to do is copy the x values. So we're going to copy them in numerical order from the smallest to the biggest. So the smallest one would be -7, then -5, then it would be 6, 7, and 9. And then I will copy the y values, which would be, starting with the smallest, would be -7. Then would come -1, then 0, and 4. And then I'll just connect the points as the order pair shows here. 7 and -1 would connect. 9 and -7 would connect. 6 and -1 will connect. -5 and 0, it's right there, with connect, and -7 and 4 with connect. Okay. If you have an order pairs, a coordinate plane, basically just plot the points. So it'd be 7, -1, then 9 and -7, and then 6 and -1, and then -5. Whoops, -5 is outside. 0, and then -7, -4. This point's right there. And if you notice, as I move my pencil across from left to right, I'm only touching one point at a time. Okay, so that's an indication that this is a function, just like we concluded before. Making a table, just basically, you can just copy these guys right here. -7, -5, 6, 7, and 9. And copy these guys here. -7, -1, 0. Oops. Be careful. You can copy this one, but then you make sure that you pick their corresponding number. So -7 is -4, and I noticed there that I make a mistake. It's supposed to be a -4, so I apologize for my mistake there. And then -5, -4, 6, -1, 7, and -1, and 9, and -7. All right. Then the last thing we are going to do here in this example is show how to write the domain and range. So the domain is basically the x values. So we're going to write it down. -7, -5, 6, 7, and 9. And then the range values would be the y values. So it would be -7, -4, -1, and 0. Okay. So that would be example number 1. So let's go ahead and do example number 2 on the next page. In example number 2, here I'm given a table, and I'm asked, is it a function? Well, if you check, the x value don't repeat, so that's an indication that yes, it is a function. Also, we asked to create a diagram, so let's write it. 0, 2, 4, 6, 8, and 10. And this would be 1, 3, 7, 8, and 9. Notice there's 2 A's over here, 8, but I only write once. And now let's connect with the arrows. So 0 connects with 1, 2 connects with 3, 4 connects with 7, 6 connects with 8, 8 connects with 8, and 10 connects with 9. And if you notice, there's only one arrow coming out from each value on the domain. So then this is a function. Let's plot the points. 0, 1, be right there. 2, 3, be right here. 4, 7, 1, 2, 3, 4, up 7, be right there. And then the next one would be 6. So 2, 4, 6, and 8. The next one would be 8. So 2, 4, 6, 8, and 8. And then the last one, 10 and 9. And as you can see, if you imagine a straight line, a vertical line going left to right, I'm only touching one point at a time. Okay. Also, let's do the order pairs. So basically it would be 0, 1, 2 and 3, 4 and 7, 6 and 8, 8 and 8, and then 10 and 9. Very well. In the domain, basically, you can just look at the diagram and copy the numbers. So it'll be 0, 2, 4, 6, 8, and 10. And the range values would be 1, 3, 7, 8, and 9. Alright, very well. Alright, before we go on to the next example, I just want to mention that this is called a scatter plot because the points are scattered. Okay, So basically, whenever you have scatter plots, you're going to have domain and range as a set of numbers, like we had here. Now compare that with the next problem where we have a straight line, which is a continuous line. So we're going to have a little bit of difference there. But before anything, let's do figure out, is it a function, yes or no? So here I have a little piece of paper, and basically, let's imagine there's like this line right here. Let me get another paper here. Okay, here we go. And let me just draw a little line right there. And basically what's happening is I imagine this line and I'm going from left to right, and I'm noticing that I'm only touching one point at a time as I move from left to right. Okay, I'm never touching 2 points at the same time. And let me clarify that by drawing another function here. Another relation. And if you notice here, if I was to draw move this line from left to right, I'll be touching 2 points at the same time. And that's an indication that is not a function. If I'm only touching 1 point at a time, it is a function. Okay? So remember, the vertical line test is if you're touching only 1 point at a time, it is a function. If you're touching 2 points at a time, then it's not a function. Alright? So we know that this is a function. Now the domain. Okay? The domain is, imagine a line going from left to right, and it says move from left to right. What is the first place I touch the line? Well, the first place I touch the line is that little arrow right there. And what that arrow means is that that line is going to go forever. So in reality, when my pencil is over here, the pencil is touching the line. It's just that the line is way up there. Okay, is way up that you cannot see. But so that means, in other words, that the domain starts at let me erase this. Starts at what we call negative infinity. Okay, and basically negative infinity you always open with a parenthesis. Okay, so now if you imagine your little line going from left to right, and let me get a better let me use a paper clip. Maybe this will be better for you to see. Okay, so here I have a paper clip, and basically what you're doing is we're imagining a line going from left to right, and the first place I touch is the arrow, which means infinity, and as I move from left to right, the last place I touch is another arrow, which means it's going to infinity. So it starts from negative infinity to positive infinity. Now for the range, you imagine your line or your pencil moving from bottom up. So starting from the bottom, as I move up, where's the first place I touch the line? First place I touch the line is at -4. So I put -4. And because this is solid, you're going to put a bracket. Okay? And later on we'll see when it's not solid what we're going to do it instead of a bracket. Okay? But for right now, we're going to put a bracket because when we touch the line, there's a solid line right there. So this is -4. And as I continue moving up, where is the last place I touch the line? It'll be right here where the arrows are. And if you remember, arrows means infinity, and it's going up to positive infinity. So that would be my domain and range for this problem. Alright. So remember, if you have a continuous line, you're going to have this what we call intervals. Okay? Alright. Let's go ahead and move on to example number 4. Example number 4 is a scatter plot, because you have a whole bunch of points right there. And okay, first thing we ask is it a function? Well, using our vertical line test, so let me we start from left to right, and as we move from left to right, is there any place where I touch 2 points at the same time? And if you notice right here, I'm touching 2 points at the same time. So that's an indicator that this is not a function. Okay. Alright, or you can just write no, not a function. Alright. Alright. Now we're going to do the domain. So domain, you always go from left to right. And what's the first place I hit a point? First place I hit a point is at -4. Then the second point would be at -2. Then the next point would be at 0. The next point would be at 2. And the last point would be at 4. Okay, notice that the number 2 happens twice because I have 2 points right there. But you just have to write it once. So -4, -2, 0, 2, and 4. Now for the range, you're going to start from bottom up. So starting from the bottom, where's the first place I touch the point? First place is at -3. Next point is at -1. Next point is at 2. And then 3, 4, and 6. Alright, very well. So that is my domain and range for example number 4. Alright, let's continue forward. Next problem, we have a diagram and we ask, what is this a function? And if you notice right here, there's 2 arrows coming out from the domain. So that means no, it's not a function. To be a function, you can only have 1 arrow coming from the left, pointing to the right. Alright, the domain is very easy. Just copy the left circle, which is 3, 4, and 5. And the range would be 1, 2, 3, and 4. So the domain range is pretty easy if you have a diagram. All you have to do is copy the first circle for the domain, second circle for the range. Alright, let's turn the page and go to example number 6. Example number 6, we have a continuous diagram, a continuous graph. So that means we're going to have intervals now for the domain and range. Okay. But first of all, let's decide if it's a function, yes or no. So if I move my pencil from left to right, I notice that I'm only touching 1 point at a time. So that's an indicator that it is a function. Now for the domain and range, you start from left to right, and the first place you touch is -4. Now notice that it's an empty circle, so you're going to use parentheses for your starting point for the domain. And as you move your pencil from left to right, the last place you touch the line is at this point right here, which is a solid point, and is at 0.4. So that means you're going to close with a bracket because it's a solid point. Now we're ready to do the range. So the range, you're going to go from the bottom up. From bottom up, what is the first place I touch? I touch at -4, and it's an empty circle, so parentheses. And last place you touch is 4, and because it's a solid line, we make a bracket. Okay. Alright, let's continue on. Is this a function? Well, if you notice, if I put my pencil there, I'm touching 2 points at the same time, so that's an indicator that that's not a function. The domain, from left to right, the first place I touch is at -4, and because it's a solid line, I'm going to put a bracket. And as I move from left to right, the last place I touch is at +4. Now for the range, it goes from bottom up. So from bottom up, first place I touch is at -2, and last place I touch is at +2, and both are going to be brackets because I'm touching a solid line. Alright. Next example, example number 8. Again, use your pencil to decide if it's a function, yes or no. And because I'm touching 2 points at the same time, it's not a function. The domain, you're going to go from left to right. So the first thing I touch from left to right is the arrow, and the arrow means -infinity. And as I move to the right, the last place I touch, the first line is at -3. So I'm going to put -3. But that's not the end of it, because I see the graph happening again at 3. So I'm going to do this. I'm going to put or, open bracket, 3, comma, And as I move on from left to right, the last place I touch is infinity. Okay? And for the range, you start from the bottom up. First place you touch is the arrow. Arrow means infinity. And last place you touch is positive infinity. So that is example number 8. Okay? Alright. For example number 9, and for the purpose of this class, we're going to do some sketches of the graphs. So this is a quadratic function. A quadratic equation. So basically the graph is going to look like this. And the question is it a function? And if you do the vertical line test, yes it is. This line here is a linear function, and the graph might look something like this. In reality it looks, let me erase a little bit. It's going to look something like that. So if you notice, if I do my vertical line test, I'm only touching one point at a time. So that means it is a function. The cubic function is going to look something like this. And again, this is a function because I'm only touching one point at a time. So yes. If you remember this from lesson B1, this is a absolute value function, and basically is going to be like a V shape. It looks something like this, and again it is a function. Now for this one, if you notice, the x and the y is kind of reversed, so that means it's going to look something like this. And as you can see, this is not a function. Okay, so for the purpose of this class, we're just going to remember that the quadratic function is going to look something like this, a U shape. A linear function just looks like a straight line. A cubic look like something like this, like a half a parabola going down and a half a parabola going up. And the absolute value is the V shape. And if you have x equals y squared, then you're going to have something like this, which is like a parabola sitting on the side. And that one is definitely not a function. Okay? Alright, let's go on to the next problems. Alright, here's the next problems, and what we're going to do is we're going to do function notation. Function notation is a formal way to write and refer to values in a function. So for example here, I have two functions. One is function f, and the other is function g. And we're going to use function notation, okay, to refer to a value of the function. So for example here I'm asking for f of 1. So basically this is a way to tell you that x equals 1. So in other words, you copy the function, which is function f, but instead of x, who's going to replace x? Number 1. So you put 1 everywhere you say an x. Okay? And then basically we're going to calculate what is the value of the function at x equals 1. So 1 squared is 1, times 7 is 7, negative 3 times 1 is negative 3, plus 1. 7 minus 3 is 4, 4 plus 1 is 5. So the function of the function of f of x equals 1 equals 5. So in other words, you could say that you have this point, that this point is on this line. Okay? So let's do another function notation, f of 0. So basically you copy the function and you replace the x with a 0. So this would be minus 3 times 0 plus 1. This would be 7 times 0, 0 squared is 0. 7 times 0 is 0. Negative 3 times 0 is 0 plus 1. So 0 plus 0 plus 1 is 1. So f of 0 is 1. Alright, f of negative 3. Copy the function. and we're going to calculate the value. So negative 3 to the second power is 9. 9 times 7 is 63. Negative 3 times 3 is negative 9 plus 1. Okay. So now 63 minus 9, it would be 54. 54 plus 1 is 55. So f of negative 3 would be 55. Yep. Just making sure I did the right multiplication there. And now next problem is g of 2. So instead of using function of f, we're going to use function of g, and we're going to substitute the x value with the number 2. So 8 open parenthesis 2 minus 2. Basically I copy 8x minus 2, but instead of x I put a 2. 8 times 2 is 16 minus 2 equals 14. So g of 2 is 14. Alright, next one is going to be g of negative 5. So we're going to write 8 open parenthesis negative 5 minus 2. 8 minus 5 is negative 40. And negative 40 minus 2 is negative 42. So g of negative 5 will be negative 42. Alright. Now we're going to do the next problem, which is still dealing with function notation, but instead of having an equation, we're going to have graphs. So here I have two graphs. One is the function of x, and here is the function of g. And I'm asked to calculate or to find the value of f of 0. So in other words, what is the value of the function when x equals 0? So look for x equals 0. And then where at x equals 0, which is this line right here, okay, is how high do we have to go? Well, we have to go 1, 2, 3. So that means the f of 0 will be 3. So f of 2, basically you're going to go to x equals 2. So 1, 2. And where is the y value? How high do I have to go to touch the line? Well, in this case, I don't have to go up nor down. I stay there. So that means this would be 0. Okay. So basically, this is asking how high do I have to go to touch the line? So f of negative 4, go to x, where's x equals negative 4. So negative 1, negative 2, negative 3, negative 4. And how high do I have to go to touch the line? Well, in this case, I have to go down 3. So this would be negative 3. Okay. Now, the next two problems, you kind of do a little twist here, because now it's asking for all the values of x such that f of x equals 0. So they're asking for all the values of x where the function is 0, high, tall. Okay. So for example, here is the here's the function, and where is the point on the line where the line is 0, high, tall? Or in other words, when the function is 0, that means y equals 0 right here. Where do I touch the line? Well, I touch these 2 points right there. And what points that gives me that value? What values of x gives me these 2 points? The values of x that give me these 2 points is negative 2 and 2. Let's look at another example. Find all x values such that the function has a height of negative 3. Well, the height of negative 3 will be right here. And where do I touch the line? Well, I touch right here and right there. And what is the x value of these 2 points? Well, the x value of this guy here is negative 4. And of the other one would be at 4. Okay? Alright, very well. Let's continue on. And let me just give me a second here. Okay, now we're going to continue the problems. We just have to make a few corrections here. I made a typo here. This is supposed to be g of 0. And so is this supposed to be a g of 0 also. So I apologize for my mistakes here. So let's change these to G's. Okay, so basically here from problems F to J, we're looking for the function of G. So basically we're going to use the second graph, which I have a copy right here. And basically I'm asking, what is the value of function G, or how high is the function at when x equals -2. So go to the graph and find x equals -2, which is right there. And how high do I need to go to touch the line? Well, I'll have to go down 1. So my answer would be g of -2 is -1. Let's do g of 0. So you go to where x equals 0, and you find where you have what do you do to touch the line? Well, you have to go 5 down, so that means this would be -5. Okay, and the last one is g of 3. So you go to x equals 3, and where would you have to go to touch the line? Well, you would have to go up 4 to touch the line, so this would be 4. Alright, and the next question is, find all x values such that g of x equals -1. Well, g of x is how high the line is, and what we're asking is that the height is -1. So in other words, we're looking here, and we notice that the 2 points that is at -1 is when x equals -2 and when the x equals 2. And the last one is find all the x values such that the g of x is -4. So basically looking at height of -4. Okay, so -4 would be 1, 2, 3, 4. And what x values gives you that height of -4? Well, the x values that give you that height would be -1 and 1. So that's your answer right there. So this concludes then the problems for lesson B1 part 2, and here's your assignment out of the textbook. Okay, remember, if anything asks you to graph, you can always use the graphs that I provided you, so cut and paste it. If it doesn't ask for a graph, then just do the problems like you normally would do. Okay, also notice here that you don't have to do problem 2C, but all the other problems in the practice problems needs to be done. Alright, so this concludes the lesson. So thank you very much for your time, and have a great day.